geometric series. So, unlike arithmetic series, this time if we look at each of the terms, the rule to get from one term to the next term is we multiply by the same thing. So if we multiply 5 by 3, we get 15. If we multiply by 3 again, we get 45, and so on down the line. This is a series rather than a sequence because we've got the pluses in between. So same sort of symbology here. U1 is the first term, then U2, U3, and so on. So the subscript there tells you which term it is. And then very similar notation here, the three things you care about are A, the first term, which is 5 in this case. So it's the same symbol there. A is always the first term, arithmetic or geometric. R is the common ratio. So it's what you times one term by to get to the next term. The reason we call it a ratio is if you imagine doing that number divided by that number, you get 3. If you did that number divided by that number, you get 3. It's like the ratio of the two numbers between each term. And then n, just like with arithmetic, is the number of terms. So I've got 6 terms along my sequence here, and so n is 6. If we look at how we form each term in general, so u1 is just the first term, it's a, just like it was with arithmetic, but this time we're multiplying by one lot of r each time. So multiply by r once, we get ar, multiply it by again, ar squared, and so on down the line. If you notice what's happening to these powers related to which term it is, the sixth one here, it's like we had the first term and then we times by the common ratio 5 times. This number is always going to be lagging one behind this number here. And so in general, the nth term here is whatever the first term was, a, multiplied by n minus 1. It's lagging 1 behind that. Notice that it's only the r which is to this power, is not the a. Okay, let's have a go at an example. So, we've got an example here. They've told us it's a geometric series, so that means we're going to be multiplying by the same amount each time. It tells us what the second term is, and it tells us what the fifth term is, and it asks us to work some things out. With these, what we need to do first is always work out what a is, work out what r is. The easiest way to do is to form equations using that general equation we had before. So, if we know that the second term here is 48, well, the second term we could write it as a multiplied by 1 lot of r. The fifth term is a multiplied by 4 lots of r, so a to r to the 4. And I've written what both of them are equal to. Just like with the arithmetic, we've now got simultaneous equations to solve for a and r. The trick here is because they've always got an a at the start of each of them. If I did this equation here divided by this equation here, then the a's would cancel out. A divided by a just cancels out to 1. R to the 4 divided by r gives us r to the 3. And then that one divided by that one, well, that's 6 over 48. You can stick it in your calculator if you want, but it's 1 over 8. To find what r is now, we could cube root. Again, feel free to stick it into the calculator. Cube root of an eighth is 1 over 2. It's like cube root at the top, cube root at the bottom. And so we've got r. It's a simultaneous equation, so now we've worked out r, we can stick it into either of these, the top one looks easier, to work out what a is. A multiplied by a half is 48, and so dividing by a half or times by 2 gives us 96. If we want it now, we could write out the series. So the first term is 96, so it's 96. The next term will be 96 times a half, so half of 96 is 48. Half of that again is 24, and so on. We're just halving as we go along. Notice that this geometric series is getting smaller each term because r was less than 1. There's nothing wrong with that. Right, if we look back at the questions here, it says find the 10th term. Well, the 10th term, u10, is a multiplied by r to the 9, which is the first term, 96, halved 9 times. Stick it in your calculator, I got 3 over 16. I'll leave it as a fraction rather than a decimal. And then this next bit here, what happens to the size of the terms when n gets large? Well, we keep on halving. If we keep on halving 96, they're going to get smaller and smaller. So they get smaller. We can say that they tend to 0. If you keep halving something, eventually it just gets so small that it's essentially 0. Right, I've got a question for you to have a go at. So I'll put it on the screen. Here it is, it's quite long. I'll let you to pause this, it will take you a while, and then in a minute unpause and we'll go through the answer. Okay, so just like before, they've told us it's geometric series and they've told us two of the terms, so the third term and the fifth term. I've written them out over here. So the third term, AR squared, is 40 and AR to the 4 is 160. Doing the same trick as before, this second one divided by the first one, the a's cancel out and we get r squared equals 4. It told us in the question that r is positive. So when I square root, I'm just going to take the positive square root. So r is 2. Sticking that into either of these equations up here, up at the top one, we can work out what a is and we get a is 10. And so writing out the series, we know that the first term is 10. And to get to each next term, we multiply by 2. So 20, 40, 80, 160. Remember we've got pluses in here because it's a series and not a sequence. It's not just a list of numbers. The second part of the question here, given that r is negative now we're out at the first 5 terms, the only difference here is when we had r squared equals 4, when we take a square root, we're meant to worry about plus and minus. Before it told us it was positive. When this new one, it's told us it's negative. So we'll take the other square root. R is negative 2. Most of the rest works out the same. A is still 10 because negative 2 squared here is a positive still. And so our series goes 10. And then if we multiply it by minus 2, we get minus 20. If we multiply it by minus 2 again, it becomes positive. 40, minus 80, 160. Notice that half of these, well, 10, 40, 160, those are the same as before. But every other term picks up a negative. The reason that didn't happen on the one we were doing before, when we had this one here, r cubed equals 1 over 8, it's very tempting to think, oh, we could have also had r equals negative a half here. That's not true. It's only when you're taking even square roots, so square root, fourth root, sixth root, and things that we get the plus minus. If it's an odd power, it's just the positive version of these. You might want to try some numbers in your calculator to justify that to yourself. Right, you've got everything you need to do exercise 3C. Cool.